driver board. This one goes into an Independence Day, and I have it being driven by my MPU, which currently has a Harley-Davidson ROM in it. And here we can see that solenoid 3 is locked on. And so I've used the built-in information services, I'll call it, of the White Star board set. And this tells me that solenoid 3 is a 50-volt coil. It's fused by F6, a 7-amp slow blow fuse, and F21, which is a 3-amp slow blow fuse. I did find F21, which is the second one, blown, so I have replaced that with a 3-amp slow blow. And it tells me, in addition to the connectors where power and ground are connected to the coil, that Q3 is the offending transistor, or in this case a FET. So Q3 is right here. So I'm going to take this over to the bench and test it. Well, here we are on the bench with this White Star driver board. And one thing I always do on these is I replace, this is the power input header, the 15-pin header. And I just wanted to point out, this is as much solder as you need. In fact, you can get by with less solder than this. We do not need to be making these big balls of solder on all the header joints. A lot of people will say, go through and reflow all those header joints. That is going to fix something in about 0.110% of the time. So let's get back to fixing this board and getting me off of my soapbox. I have my trusty Fluke 179. So I have repaired the power driver board by replacing the shorted FET. And I had to use 3 of these. These are circuit board repair eyelets or rivets. You can see the size and the part number. I got them from Mouser. And here's what you can do if you're trying to make it look clean, although in the camera it doesn't look that clean. There are 3 rivets that I had to drill out the through holes, insert the rivets. These 3 rivets are they're too large to put in without grinding this side off of the top one and the top side off of the bottom one. I've made sure that all these lines are all connected to where they're supposed to go. That's the biggest problem that I see with FET replacement on the White Star MPU board. Probably the SAM also is. The lower leg of the FET. Well, my camera ran out of memory, but here in this beauty shot, you can see the FET in the center is my work. The stuff to the left is somebody else's work. And you can see how I've connected all of the necessary drive and drain connections to this FET. And we are back on the bench. And I'm about ready to cycle coils. And here we go. That was the one that was not working before, 3, which is right here. I'll let that come around again. This video might be a little choppy. I was running out of iPhone space. Like living on the edge of iPhone space with 128 meg, I guess, or gig, 128, whatever. And I keep making videos, and then I'll have to post them, and then delete them, and then really delete them, and I just need to go get a bigger phone. There's the one. I'll test it again. I missed one of these as it went by, so I want to see it again. Here's 7. If I blink or change my view from the phone to the real world, I'll sometimes miss something. Now, 15 and 16 were a little longer because those are flipper coils. Actually, let me go back and look at that. 16's the right flipper, 15's the left flipper, 14's a magnet. So along the way, as I was repairing this, you can see I did get Q3 successfully replaced. I installed 2 beefier FETs for the flipper circuits. So those should last a lot longer than the P2010NL or something like that that they had in there before. Anyway, all these drive circuits are working correctly for the coils, and let's test the lamps. This is my homemade tester, and that is the White Star lamp test. Flashers is a rehash of some of the solenoid circuits. It's nice with Harley-Davidson ROMs because it's always the last 8 coils. And that is it. This driver board is good to go. Once again, replaced 1 FET, 2 3 FETs, replaced fuse F21, replaced the power output header, which is critical. And the power coming off this board is about 5.0 even. Thank you for sending it.